Welcome everyone to our YouTube series, Test Prep Made Easy. So in this particular series, we are going to post regularly questions on our YouTube channel. The questions will pertain to CAT preparation, maybe pertaining to GMAT preparation, as well as of various topics which are tested in these particular exams. For example, quants, LRDI, English, and various areas which are tested. And each day we will handle certain number of questions and their video solutions. The best approach is to these questions in these videos. So have a happy preparation ahead and enjoy the video. Thank you.
All right, so these are the questions that we are going to try in today's video. If you have tried it already from the thumbnail, good enough. If you haven't, you can pause the video at this point and try it once before you look into the solutions. We recommend you doing that. But if you just want to enjoy the solution, that's also good enough. And go ahead and watch the solutions now. Okay, so this is a type of question which has appeared in a lot of different aptitude exams somewhere down the line. We have been given two sides of this triangle. So a couple of sides have been already mentioned, 8 and 15 centimeter. And the third side is missing, so that is represented by this 8 centimeter. But there is a condition given, which is a is an integer. So that is mentioned. And we're looking for how many such triangles are possible, but do not miss out this point. It's an obtuse angle triangle. So I have discussed this thing in our classes as well. Do keep in mind in this way, it is something you don't have to by heart, and also you don't make a mistake. A couple of things to consider. First of all, it has to be a triangle, and in a triangle, it has to be an obtuse angle type. So I'm focusing first on the obtuse angle. I mean, typically for a triangle, you have to check sum of two sides greater than the third side. I'll come to that in a while. But for an obtuse angle triangle, the idea is very simple. So if you take a right angle triangle to begin with, always compare it with right angle. It's very easy to do. You don't have to do this all the time. Just understand it once. So if I consider a right angle triangle, suppose the sides are A, B, C, where C is the longest side. So what does Pythagoras tell us? C square is equal to A square plus B square, right? So if I take an obtuse angle, which is having this angle more than 90 degree or something, and I keep the A and B constant, just imagine it in this way. So obviously the C is bound to increase, right? As long as this A and B are constant, the new C will be more than this C, isn't it? So effectively the C square will now be greater than A square plus B square. So always compare with the right angle triangle. It's easier to do that. But the comparison point is on the longest side. That is always the case. So effectively what we are going to do is we are going to consider which is the longest side. So there are two possibilities out here. One is that A is the longest side because that is missing, could be the longest side. And another scope is 15 is the longest side. So out of the two known sides, I hope you can see that 8 is less than 15 any which way. So that cannot be the longest side. So there are just two cases out here, right? Either A is the longest side or 15 is the longest side. Now, again, when you are checking for a triangle, I mean, the triangle inequality tells us that sum of two sides is greater than the third side. Sum of any two sides is greater than the third side. You always have to check sum of the two shorter sides being greater than the longest side or not. That is the check you have to make. So when A is the longest side, the two shorter sides must be 8 and 15, right? So the sum of these two should be greater than A. This is the first condition. In order for these three numbers to form a triangle, or rather form the sides of a triangle. So 8 plus 15 has to be greater than A. Also, the thing that we understood just now, because it's an obtuse angle, it has to be obtuse angle. The longest side square has to be greater than 8 square plus 15 square, right? So notice how am I representing this? So I'm not looking at this part anymore. I'm just imagining it with respect to a right angle triangle. That's what I'm doing. So for right angle triangle, the longest side A square will be equal to 8 square plus 15 square. For obtuse, it has to be greater than, right? So just use these two in conjunction. So there's an and out here. Both of the conditions has to be met. So first of all, look at this. So this is pretty simple. A has to be less than 23, sorry. It's pretty straightforward. Here, so this is the lower limit of A square is greater than. Now, if you know a bit of Pythagorean triplets, you'll know 8, 15, 17 to be a Pythagorean triplet. So 17 square doesn't work because 17 square will be equal to 8 square plus 15 square, or you can work it out. If you are not aware of this triplet, 8 square is 64, 15 square is 225, added is 289, which is 17 square. So A has to be greater than 17, right? So that has to be there, because taking this as 17 makes a right angle triangle. So effectively, in this range, we can take up values of A. Just count how many are those. So 16, 17, 18, 19, 20, 21, and 22. Sorry, it's not 16, my bad. Starting with 18, my bad. So 18, 19, 20, 21, and 22. So there are 5 values. And of course, the same drill for the other case. So that is 15 being the longest side. So 15 is the longest side. The other two sides, or the shorter sides, are A and 8. That should be greater than 15. And this 15 square should be greater than A square plus 8 square. So that's it, right? So A plus 8 greater than 15 implies that A has to be greater than 7, 15 minus 8, that is. And if this thing you check, I mean, just evaluate these two squares in this case. So 15 square is 225 and 8 square is 64. So just subtract. This has to be greater than A square, right? So if you just check this, this is coming out to be 161, right? Yeah, so it comes out to be 161. So I can't take A as 13, right? 13 square is 169, but A equal to 12 is acceptable. So I'm going to say something like this. So up to 12 is allowed. So the possible values of A are 8 to 12, that is. So 8, 9, 10, 11, 12. So another 5 values. So don't miss out this range, otherwise you'll get a wrong answer, and you have 5 as an option. So there are two possible cases, or two possible range of A, giving us a total of 10 possible values, and that should be the answer to this question. So I hope this was understood. I mean, this type has appeared a lot of times in a lot of different aptitudes, and this is a very common type of question. This is the easiest way to approach these kind of questions. You have to remember very less kind of things, and you can visualize these kind of things very, very easily. So I hope everything was understood that I discussed. If there was any issue understanding or how to visualize this properly, then do mention that in the comment section. We will take them up. Thank you for joining in. Okay, so this is a time and work problem. We have 20 workers and they can reap 120 acres of land in 30 days, working 6 hours a day. Now, okay, so this information is given. So in these kind of questions, I typically always check what is required. So let me go ahead and do that. Now we're looking for how many more acres of land. So we're looking for how many more acres of land. Great. Can 30 workers working 12 hours a day reap in 15 days? So a couple of things I'll mention straight away. So first of all, when I solve this question, I'll be finding the acres of land that the new set of workers can reap, whatever new time available is there, for. But the question is looking for how many more. So I have to subtract 120 from that value to get the final answer. Don't make a mistake there, first of all. And secondly, what you have to understand is the time part that we have. The main focus is in terms of hours, right? I mean, it's not in terms of days, because I can just merge these two information together. So they work for 30 days, working 6 hours a day, and in combination I can say that the initial set of workers were working 180 hours, right? So there's nothing to do out here. And same thing I can do for this part as well. 12 hours a day for 15 days. So total amount of time they're working for is 12 into 15, which is 180 hours. I mean, this is something that happened I did not expect. Let me check whether that happened actually or not. Yeah, so it did happen. I mean, that is correct actually. But this is not the motive behind it, by the way. This is just coincidence that happened. But yeah, I always do this. The main focus and time is in terms of hours, right? Total hours they have been working for. The interesting part that I found after doing this is that there is no change in time actually, right? So whatever change is going to happen is because of changing the number of workers, right? So we are making the workers 3 by 2 times. So initially we had 20 workers, now we have 30 workers, right? So if you have more workers, we can do more work, something like that. So we can now effectively do 3 by 2 of the original set of work, which is 120 acres or something. We have to take this proportionality because nothing else has been mentioned. So effectively now they can reap 180 acres of land. But remember, we have to look for how many more acres. So the answer will be 60. So pretty straightforward question, hardly 10 seconds if you observe that 30 into 6 and 12 into 15 are same. So there is no change in time at all. But yeah, I mean, even if that doesn't happen, you can work around with it, right? So had this being a different time, you have to take that part also into account along with the, number of workers. So that's it for this question. Hopefully this was fun to understand. And I hope everybody understood the entire thing as well. And thank you for joining in. Okay, so we have a question on log. Now, we can actually solve this in a lot of different ways. So what I'm going to do is I'm going to try and simplify the left-hand side here with as less amount of operation as possible. Now, in order to do that, let me explain one idea here. So if I have something like, let's say, log of a square to the base b, if I have something like this one, the power comes down, right? So this is a property you might be aware of. I have discussed the reasoning behind these kind of properties in our classes. On the flip side, so if I have something like this, so there's a power in the base, this comes out directly in the denominator. So I hope you can understand what I'm saying. So instead, I mean, there's a power of 1 here. So the 1 comes out in the numerator and the 2 comes out in the denominator, right? So in a conjunction, sometimes this is helpful. So by the way, the remaining part will be this. So I'm taking out the power, but that will come out in the denominator. So in conjunction, you can say something like this. So if I have something like log of a cubed to the base b to the power 4, I can directly take these two powers out. I can take the 3 out in the numerator and 4 out in the denominator and leave this as something like this. So this is an interesting idea you can remember. We can use this idea directly. So for example, leave the log x base 3 as it is. The 9 that we have in the second base, base of the second literal, that is 3 square, right? So I can take it as half x base 3. So this is 3 square, right? I hope you understand this. I'm using the same idea that I explained just now. This is in the base. So this will come out in the denominator, right? And the remaining part will be log x base 3. And same thing here, 27 is 3 cube. So we'll have a 1 by 3 log x base 3. And this is 3 to the power 4. So 1 by 4 log x base 3. So now we can, what we can do is actually we can take this log x base 3 common, and what we have is something like 1 plus half plus 1/3 plus 1/4. So before I go ahead, let me evaluate this. This is anyhow a rough work. So I'll just take this as 12 and the LCM. So we have 12 plus 6 plus 4 plus 3, right? So 10 plus 15, so that is 25 by 12. So this extra bit, whatever is multiplied to log x base 3, evaluates to this. So left hand side, what we have is something like this: 25 by 12 log of x base 3 is equal to 25 by, sorry, 25 by 4, which is given right in the question. So just cross multiply now. So what you have is log of x base 3 is equal to 3, right? Because this goes as 12 by 25, 25 cancels off, and 12 by 4 is 3. And now just use the basic idea of log. So whenever you have this x is 3 raised to this 3. So this is the base, this is the power. In this case, both are 3, so don't get confused. So, but I hope we got which one is base and which one is power. So this is the base, this is the power. So 3 cube, so that is 27, and that should be the answer. Find x, right? 27 as our answer. So pretty straightforward question, nothing too much to do. It's hardly a 15 to 20-second problem if you know this idea. The only thing you have to calculate is this thing, and the rest is pretty simple. Uh, yeah, that's all I had to add to this question. Hopefully everything was understood. Thank you. Okay, so we have a PNC question here. Now it says how many ways can the letters of the word couple, so all are distinct by the way, be arranged so that no two vowels are together. Okay, so this is an application of the gap method when it comes to PNC. We are looking for how many ways we can arrange the letters of this word so that no two vowels are together. So whenever you have a question like this, so the first thing you always understand is which part the constraint is on. So the constraint is on the vowels, right? So if the constraint is on the vowels, the one which doesn't have the constraint are the consonants, right? So what are the consonants? You have C, P, and L. So these are the three consonants. So first, forget about the vowels and try to arrange these three among themselves. The number of ways you can do that is 3 factorial, right? So let us say that we have arranged the C, P, and L in these three places, right? And the number of ways we can do that is 3 factorial. Now, what happens in each of these cases? So first, for example, let's say I place the P here, the C here, and the L here. So this is one case out of these 3 factorial ways, right? And now the interesting thing is, so this is the gap method, by the way. There are a lot of different applications also, strong applications actually. What you can observe is if I place a vowel in any of these spots and only one vowel in any of these spots, then the vowels will never come together, right? So what I'm trying to say is, as long as I'm not placing two vowels together in one of these I mean, wherever these arrows are pointing to, the constraint doesn't break, right? The vowels will never come up here or come side by side, right? But the point is, we have just three vowels, isn't it? We just have O, U, and E in the given word, that is O, U, and E, right? So out of these four pointers, I mean, four gaps or something, wherever these arrows are pointing to, I don't require all the four gaps, right? I just need three gaps because I need to place these three vowels in them. They have to be separate places, but I just need three of them, right? The fourth one will always be empty. So what happens is corresponding. Now, this is the important part. This is for each and every case. For example, when I'm placing PCL, I can select, these three gaps. I might select these three gaps. So these are corresponding in nature, right? So you need to multiply. So it's and kind of thing happening. So out of the four of these, I need to select three. So that is 4C3. Once I've done that, so suppose let me take another example. So let's say I have selected these three gaps. So in these three gaps, I have to arrange the three vowels as well. So that is remaining to be done because up till now I've just selected the three gaps, right? So the number of ways I can place these three vowels on these three selected gaps, and again that is happening correspondingly, will be 3 factorial ways, right? Three different vowels in three gaps out here. So effectively, all you do is just multiply all of this and you get the answer. So 3 factorial is 6. 4C3 is as good as 4C1, which is 4. And 3 factorial is again 6. So 6 into 6, that is 36. Cross 4 is 144 ways. So that is the number of arrangements that you have. So pretty straightforward question out here. Those who are comfortable with PNC, I hope you've definitely got the answers here. Those who have not, I hope this helps you a bit. PNC, I mean, it's just a structured way of counting the number of ways of doing a certain activity. So this activity would be, in this case, just arranging these letters of this word. Might be you don't have any other work to do, so you're doing that. But yeah, that's the objective of this question, right? So all you do is just find a structured way of counting those number of ways. That's all PNC is. So we have a good blog actually in our website. You can go and visit that. It should clear the basic idea of your PNC. For advanced understanding, you can take our courses as well. I mean, there's a capsule. There are a lot of different capsules for basic PNC, for advanced PNC and all. You can choose whichever you want to start with. Um, they are very low price capsules as well. But in this case, the blog will be definitely helpful. So I'll leave the link of the blog in the description of this video. Do check that. And this is just a 15 to 20 minutes read. You don't need to, sit with a pen and paper as well. Just go ahead and read it. The visual representation as well. I hope that will help you a lot. Anyhow, that's all I had to add to this particular question. This is anyhow a very straightforward one. There's not too much to it. And I hope all of you have understood this. Thank you for joining in.
Hopefully you liked the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. Do subscribe to the channel and click on the bell icon. In that case, you'll get notification as soon as we upload a new video. And if you want to check a bouquet of courses that we provide, so we have a huge variant of courses from customizability to full preparation. You can check our website www.mathoratory.com. I'll leave the link in the description below. And have an enjoyable preparation ahead. Welcome to the Mathoratory family and have a good exam ahead.